Good morning, everyone. Today we'll be learning binary computing. For that, we should know that computer is a digital machine. Computers are electronic machines. They understand data in digits, digits which are zeros and ones. Computers need to translate this data from analog to digital. As you can see over here, it's the diagram of digital data. Digital data is in the form of digits, like at the start it's 1 and then 0, then 1, 0, 1, 0, and it's the combination of those digits. Similarly over here it's analog signal. Analog signal, if we compare it with digital signal, it's continuous. It's kind of, there are no gaps between these signals and it's continuously flowing. On the other hand, these digits are switching off and on. 1 means signal is on and 0 means no signal. There are gaps between these digits. Digital signal is kind of discrete and having zeros and ones. And analog signal is continuously flowing. Forms of data. Data is a collection of raw facts and figures. We have studied it before. It's meaningless, often meaningless. So we should know there are 3 types of data, whatever it is. It's not other than that. The very first form, numerical data. Numeric data, which is the numbers itself. As you can see over here, the numbers 1, 2, 3, 4, they are numeric data. Second form of data is alphabetic data. As the name suggests, it's alphabet letters from A to Z. All the data in the form of alphabets, it's called alphabetic data. And then it comes alphanumeric data. Alphanumeric data is kind of different than numeric and alphabetic data. Why is it different? Because it's having symbols in it. Symbols, there are many symbols given on keyboard, which are decimals, commas, colons, equal sign, percentage, different functions, and many others. So they all together come in alphanumeric data. Now we'll be knowing about digital data. When data is processed, we get the information. Computers process large amounts of data after converting it into a digital form. All those forms of data are converted into zeros and ones. As you can see over here, the large strings of zeros and ones in thousands or millions. Binary states. We should know what the binary states are. The first one you should know is by means 2. By is for 2. In case of current flow, we have only 2 situations. Either current flows or it does not. These 2 situations are represented by zeros and ones. Binary state on is your 1. Signal 1 is binary state on, in which this bulb is switching on. And the other state is 0. Signal 0, which means off. The same situation we can observe in memory unit of a processor. The CPU works with these signals. Whenever we press a key on keyboard, electronic signals are sent to the processor, and then it works accordingly. The processor understands these signals and processes them very easily. But humans cannot see those electronic currents. That is why we represent these signals as ones and zeros. Data in the form of ones and zeros is called binary data. Any data which is in the form of zeros and ones, a combination of zeros and ones, is called binary data. We should know if we input 10. 10 means the number 10 in decimal. If we input through keyboard, it's changing it into 1010, which is binary data 10. Over here, 1010 is representing this number 10. Similarly, the 2 is represented as 10, which is 10 again. And if we enter 12, it's 1100 in binary data. It's the conversion which is being done in processor by itself. Number systems, we use numbers to mean different things. We use the digits from 0 to 9 to represent small numbers from like 0 and like 2 and 5, and large numbers like, as you can see over here, 5900 and 99723. There are many other numbers which we represent like that. We should know the system uses 10 digits. 10 digits are, whenever we are using 10 digits for any number system, that will be the decimal number system. Decimal number system is having base 10. Why is it base 10? It's because this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They are the base of this decimal number system, and we are not having any number which is other than those numbers which are given over here from 0 to 9. All those numbers are coming in between these 0 to 9. Like if I talk about 12, 12 is the combination of this 1 and 2 itself. The number from 0 to 9, that's it. They are the base of this decimal number. And all those numbers other than that, which we are using in our daily lives, they are the combination of these numbers which are given as a base 10, starting from 0 until 9. There's not any other number which is not coming under this base. There's another number system having 2 digits. That is called binary system. Binary number system is combination of ones and zeros, as I told you before. Decimal 10 is represented as binary 1010. The types of number systems, we should know in this lecture that there are 4 types of number systems. The very first one which we are using in our daily lives, and we all know about it, it's decimal number system. It's starting from 0 and going till 9. And what is happening afterwards? The 10 is a combination of 1 and 0, which is already there, ones and zeros. And similarly 11, this is a combination of this 1 1, and then 12, combination of 1 and 2, and so on. This is all about decimal system. We are very much familiar about that. What about the other system, which is hexadecimal number system? That is being used inside the computer, and it's very common between processors of different types. So what they are doing, they are converting our numbers which we are inputting through our keyboards. They are changing it into hexadecimal number systems or octal number systems or binary number systems. It depends upon the processor and its speed and its type. If it's hexadecimal number system, the if it's based on hexadecimal number system, it will be a combination of numbers starting from 0 and going till f. What does that mean? It means these are all the numbers which are the base of this hexadecimal number system, starting from 0 and going till f. How can we calculate them? The very first 0 is your number 1. If we calculate, hexadecimal number systems are actually 16 number system base. It should be, as the decimal number system having base 10, the hexadecimal number system is having base 16. So 16, so these numbers should be 16. These numbers should be 16. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Till F, there are 16 numbers. That is why they are hexadecimal number systems, base 16, and afterwards it's the combination of these numbers, as I told you before. All those numbers after this F will be combination of these previous ones. Now we'll be learning about octal number system. The octal number system is having As you can see, 3 digits, and it's going till 17. If we calculate about these, they should octal number system is having base 8. If we look at the octal number systems, they are base 8. The base for this octal number system is 8. We should count them like this: the first 1, 2, 3, 4, 5, 6, 7, 8. Till number 007, the base 8 is completed. And what's happening afterwards? 010 is a repetition of those numbers which are previously there. And then 011, it's again a combination of previous digits, and so on. This is how it works inside the computer. And now if we talk about binary number systems, they are a combination of zeros and ones. How? The very first number is 0, and then 1, and then again 0, again 1, again 0, again 1. It's repeating the combination as such. The decimal number systems, a base 10 system, is based on 10 digits from 0 to 9. These digits are combined in different ways to represent different values, and it is showing as base 10. Whenever a number is given like this, 10 and brackets, and this small 10 is a base of this number, which is showing that the number is in decimal system in front of you. If a number is written like this, 10 with base 2, it means it's binary number system, because we know that 2 is the base of binary number system. Binary number systems are having base 2 and digits, zeros and ones, and combination of these digits. This base 2 is showing that this number is given in binary number system. Octal number system is having base 8, and we can see it over here. The small 8 is showing that the number given in example is in octal number system, because it's having base 8. Base 16 is showing that the number is in hexadecimal number system. And one more thing, A, B, C, D, E, F till F, these letters are just coming in hexadecimal number system, not in any other. So we can say the number is this number in example given in base 16, which means hexadecimal number system. That's all from my side. Thank you so much.